Hi, this is Mr. Max with part 3 on my series on further trigonometry. I said I will be doing a question from the past question papers. I took one from the paper of 2021, part 2 here in Namibia. But if you don't have access, then obviously the questions are up here and you can actually try it and see. Right, so we have a couple of things that we need to take into account. R is greater than 0, so when we use our R formula, we're not going to take the negative square root. And then also that alpha is an angle that is between 0 radians and half pi radians, which means our calculator, if we deal with our calculator, then we need to set our calculator to radian mode, because the nature of how these questions are, it's always that you might be asked to calculate some sort of equation, okay, some sort of equation, and you'll see that, okay, in part 3 they will say find the smallest possible value of theta satisfying the equation that we are going to do there. That whole thing will now be set to equal to the root 2, right, square root of 2. Now obviously, meaning smallest possible value, it means an angle that is between 0 and half pi radians. Okay, then there's a B part as well, where you have a different, it's still the same topic, trigonometry or further trigonometry, but now you are supposed to solve this equation for 5 marks. Right, so let's start with the first part of the question, Roman 1. You hopefully by now I don't have to do the proof as to how or where this r cos theta minus alpha comes from, and of course if you want to, you can have a previous view or look at my other video to see where that comes from. But since I have included, I think, enough space, I might just as well decide to do so. But using the formulas directly, I can actually calculate the value of r by taking the square root of the numbers, which is 3 squared plus 3 squared. Okay, and 3 squared plus 3 squared, that's 9 plus 9, which is square root of 18. Now the square root of 18 is 2 times 9, and this can be written as square root of 2 times the square root of 9. So this answer is going to be square root of 2 times 3, which I can just leave as 3 square root of 2. And this is my r. And the reason why I'm leaving it like that, because I might have to use it somewhere where they would ask me about an exact value. Right, so how do you find the angle? Tan alpha, or in this case, yes, we still have alpha. Our b value, well, since everything is 3 over 3, doesn't really matter. Okay, so finding alpha, we have to take the inverse tangent of 1. So tan arctan of 1. Now, I do expect you at this level, from your special triangles, that you should remember that if you have a special triangle, like so, okay, you should remember, so this is 90 degrees over here, or half pi radians, and this value is 1, that's value is 1, that is root 2 from Pythagoras. This is pi over 4. We should also make that one pi over 4. Okay, and tangent is opposite over that. So my guess, what I want to show you here is that alpha will be pi over 4. Now I have my alpha, which you can obviously give as a decimal value as well, but well, you definitely know that that is what you're going to get. Right, so at the end of the day, so you have 3, so let's just write down the whole thing, 3 cos theta, but we have got, is it theta or alpha? What is theta? Our alpha was our angle, right? So 3 cos theta minus 3 sine theta is equal to our r being, if you have to go back to our r, no, that's not minus, but that's plus. Let's just make this sure that it's correct. Okay, so the cos here is going to be this. Now this is going to be minus. It's going to be opposite, the reverse of that. I'm just going to put pi over 4. I just want to bring in the value of r, which was a set from 3 root 2. 3 root 2. Okay, of course, this is the solution. And you are done with that part. I think it's 3 marks. You shouldn't be wasting a lot of marks if you know what is it that you need to do. Okay, but supposedly you don't know where it all comes from. Again, you can have a look at the other videos, but I'm just going to take r cosine of theta minus alpha and just write it over here. So r cosine of theta minus alpha. Then I'm going to use, and I hope by now you're familiar with this over here. Okay, just write the other one, 3 cosine. I'm just going to write, okay, it's not far, so I'm going to come back to it. So I'm going to have that r out now. I'm going to have cos theta. Now, if you know how to use your formula, okay, sum and addition formula, it's cos, so it's cos theta times cos alpha plus, because it's a negative, sine theta sine alpha. Okay, now before I distribute that r, I just want to do one more thing, and that is I just want to write cos alpha in front, because cos alpha will be a number and cos theta is just a coefficient. I'm going to do the same here, sine alpha and then sine theta. Now I can actually go ahead and I can distribute that r. Okay, if I have to distribute that r, it's going to be r cos alpha cos theta plus, let's go grab our r, that's r sine alpha sine theta. Okay, so let me just grab this part of the question. Let's take a snapshot of it, of course, so you can see what is it that I'm referring to when I'm doing over that. So grabbing that, I'm just going to paste it over here. Okay, I'm just going to make it a little bit bigger. Looking at the coefficients and equating coefficients there, right? The coefficient here, I have got r cos theta. I'm going to let it equal to that, and I'm going to take so let's say that is going to be my first equation, that is r cos alpha, and I'm going to say let that equal to 3. And the next one that I'm going to look into will be this coefficient here, r sine, the coefficient is sine theta, so the coefficient of sine theta is r sine alpha. I'm going to let that equal to 3 as well, and that is going to be my second equation. That's going to be my second equation. So my second equation will be nothing but r sine alpha is equal to 3. Now, if you were to take the 2 and you divide, you say you take equation 2 and you divide it by equation 1, this is going to give you r sine alpha over r cos alpha, and then this is definitely 3 over 3. Now, if you look at what's going to happen over here is that you're going to see that the r's will cancel, and you'll be left with sine alpha over cos alpha equals to 1, if I can leave it like that for now. And then obviously sine alpha over cos alpha is nothing but tan alpha from your identities, your trig identities that you should know. And at the end of the day, this is alpha will be the inverse tangent of 1, which we have determined from our answer before. Okay, remember? So I'm just showing you how one find that without, necessarily if you forget, but the formulas are definitely being provided. So let me just also at the same time, you don't have to do it, but since I'm on a roll, I'm just gonna show you also how to find the value of r. So what I'm going to do is I'm going to quickly bring down my 2 equations that I have created, these 2 equations over there, and just paste them over here. Okay. So what I'm going to do now is I'm going to take the sum of the squares of the 2 equations. So I'm going to say I'm going to take equation 1, square it, add with equation 2, and square that. Okay, so when I do equation 1, I've got r squared cos alpha times cos alpha is cos square alpha, and that's equal to 3 squared. I'm just going to leave it as 3 squared. I'm not going to work out the value. Doing the same over here, that is r squared sine alpha times sine alpha is sine square alpha, and also let that equal to 3 squared. Now I'm going to add the two equations. Adding the left-hand sides of the equations together will be r squared plus r squared cos square alpha plus r squared sine square alpha, and then adding the right-hand sides of the equations together, whoopsie, the right-hand side is going to be 3 squared plus 3 squared. Now on the left there is a common factor of r squared, and I'm going to remove r squared, and I'm left with cos square alpha plus sine square alpha, and then that's going to be 3 squared plus 3 squared for now. And I hope you do remember from your first Pythagorean identity that the whole of this value is equal to 1. Okay, so anything times 1 is just going to be that. So I'm going to have r squared times 1, which is r squared equals to 3 squared plus 3 squared. Now you will see definitely where it comes from. Now, okay, r is going to be positive or negative, the square root of 3 squared plus 3 squared. But there is something where they say r should be greater than 0. Okay, and because of that case, we are not going to take the negative value. We're going to take the positive value, 3 squared plus 3 squared, and that is 9 plus 9 is 18, the square root of 18, which is the same as 9 times 2, and the square root of 9 times 2 can be written as the square root of 9 times the square root of 2, which gives you 3 square root of 2. Now I have these values from before, and I just show you how to calculate it. And once you see that those were what I was using, I had my r, which is 3 root 2. Okay, and then you can now take your equation as it is. Okay, and then you just let it equal to that part. So you can now, after doing that, you can also do that. So of course, I just showed you how one get to the answer. Okay, and then at the end of the day, you just conclude. Um, what those values are. Okay, so that was just to show you don't have to do it the moment you have an idea, because you will be provided with the formula sheet, especially for R and for tan alpha, and then you can definitely apply that. Okay, and the point that I was making with regard to R being greater than 0, R should be a positive value, and it's right over there. Okay, so let's go to the second part of the question. Now, the second part says we must now find something that's solve that. So let us just bring the equation back. Okay, so that's how I have the equation. Basically, this 3 sine theta plus 3 cos theta, doesn't matter how it's written, right? It should equal to that. So I'm just going to take the right hand side, because since they're identical, I can use the right hand side. So I'll be saying, okay, 3 root 2 cos of theta minus pi over 4, and that equals to the root 2, of course. Now, isolate cos theta of all of that, cos of all of this family of it here, that's going to be cos of theta minus pi over 4, and then you're going to take root 2, you're going to divide it by 3 root 2. Now, of course, you can see that root 2 goes in itself once, it goes there once. So at the end of the day, you're going to have cos of theta minus pi upon 4 is equal to a third. Okay. Now, it's important because they say solve, find the possible value of theta. So we are solving for theta. But we are not looking for any theta. We know that what is the original domain is an acute angle, is an angle between 0 and half pi radians. So that is what that part means, the small possible value of theta. Okay, small possible value of theta in this case. We are going to look for small possible value of theta where the cosine is obviously positive. Okay, so you can take a cosine value where you're dealing with an angle that is bigger than the smallest possible angle, like in the fourth quadrant when you're doing that. Right, anyway, this is theta minus pi upon 4. You're going to take the inverse cosine of a third. So once you do that, make sure your calculator is in degrees mode, and radians mode, sorry. So I'm going to take the inverse cosine. This mine is already on radian mode, so that's pi upon 4. Okay, it's pi over 4. I get some value, hopefully. Is that what that value is? Of course. Now, inverse cosine of that, make sure of degrees, cosine. Oh my goodness gracious. Yeah, this is supposed to be 1 over 3 rather. What am I doing? Okay, I'm doing the reverse. So 1 over 3. Okay, so this is the answer that I get on that side. So what it now means for theta, it means that theta minus pi over 4 equals 1.230959,417. Then theta will be the same story over here. Okay, add with pi over 4 because you are now sort of adding both sides by pi over 4. Now at the end of the day, what is theta going to be? So let's just grab my calculator because I don't want to type all of that stuff in there. So theta will be, okay, that 1.20, so 230 is still programmed in my calculator, so I'm going to just add pi upon 4 to that answer. Okay, I get a very long number here that I can also capture the screen. Now you don't have those things of capturing the screen in the exams, but write them down and then only give the correct degree of accuracy as specified within your exam paper. So this is going to be in radians. So since this is in radians, I'm going to give it to 1 to 3 significant figures. So that's 2.02 radians. All right. So that take care of that part of the question because we were supposed to calculate the smallest angle. Right. We have a second question. Now, this question is unrelated to the one on top, okay? But it is also further trigonometry. Good. So you have got an equation 4 upon 10 to x. So you have a double angle that you have to know. That's why I brought this in, okay? And then you work from there. So the 4, where I have 2 tan x, I'm going to replace that with the formula. But now I'm not going to use the a, right? So 10 to x is going to be 2 tan x all over 1 minus tan square x. That's what you have to do. You use this to guide you. Okay, so this is going to be 4 upon, we have 2 tan x. Now I'm going to replace it with that whole business there. That is 2 tan x. And that one also goes over something. And that something is 1 minus tan square x. I'm going to put that in brackets. Okay. Right. So this is supposed to be add 5 equals to tan x. Now, the way you will get rid of this complex fraction over here, so if you have a fraction 2 over, let's say 3 over 5, so what you do in this, you will be multiplying by 5 both sides of this, okay? Because this is just good for the optics, and you'll see that is the answer. It's just the same value, but it just, I didn't change the value of the thing. It's just a better way of writing it, okay? So you can check that with your calculator. So I'm multiplying top and bottom by the denominator of that. So if I have a complex fraction like 2 upon 3 over something else over 5, so I'm multiplying here by 5, and I'm also multiplying 1 on top by 5. That's what I did there, and I get my 10 over 3. Okay, so what does it mean? Here, I'm going to multiply the top number here. I'm going to multiply here by that 1 minus tan square x. And I'm also going to multiply here by 1 minus tan square x, just to write that complex fraction better. So it's 1 minus tan square x now, and now it's over 2 tan x. Okay, these two things are equivalent. Plus 5 equals to tan x. All right. Now I can actually work, and remember, you need to get rid of that denominator. So I'm going to multiply throughout by 2 tan x. So if this is 1, is going to remain. Okay, if you multiply by 2 tan x, but the 5, you have to multiply 5 by the 2 tan x. Okay, and then what you also do is you're going to multiply this other tan x on that side. You're also going to multiply it by 2 tan x. All right, let's distribute and so on. So this is nothing but 4 minus 4 tan square x plus 10 tan x equals to 2 tan square x. Tan x times tan x is tan square x. Okay, right, so what do we have? We've got negative 4 tan square x. Now I'm gonna just collect already my like terms. We have minus 2 tan square x, that is quadratic because everything should equal to 0. Okay, then I have plus 10 tan x, okay, and then plus 4, everything should equal to 0. Okay, let's clean it up. We have negative 2 tan square x, collecting like terms, those coefficients there, plus 10 tan x plus 4. Now we do not like that negative 2 in front, and 2 is a common factor, so you are going to multiply, or no, I'm going to divide rather, throughout by negative 2. So I'm going to divide throughout by negative 2. If I do that, this becomes tan square x, and a positive divided by negative is a negative, and that's 5 tan x, and a positive divided by negative, that's negative 2, is equal to 0. Okay. Now, you obviously will see that we are left with a quadratic here. Okay, I just want to make sure of something because it seems that okay, right. So what do we have now as a quadratic? We have got 2. A little bit of a mistake somewhere, I believe. Let's just make sure I wrote it correctly. So that's 4 minus 4. Okay. Okay. Plus 5 times 2 tan x plus k. That is 2 tan square x. Good. We're on the right path. We're on the right path. On the right path. On the right path. I just want to see what is the issue with that 4. Okay. Does this factorize? Not really. But 2 goes into that, and 2 goes into that, and 2 goes into that. Negative 4 here seems to be my problem. I have located the source of my headache. This negative 4 and this negative 2 does not give me negative 2. Mr. Max, that's why I was wondering. So let me just clean this up because I immediately realized, wait a minute, this thing is going to be wrong. So I will also suggest that you go back. So there's negative 6 over here. Yeah, negative 6 times square x plus 10 tan x plus 4. I'm still going to divide throughout by negative 2, doesn't matter. That is going to give me 3 tan square x negative, that's minus 5 tangent of x minus 2. Now it sounds a little bit delicious. Okay. Now I can actually factorize. This is negative 6, so you multiply 2 numbers, give you negative 6, and those numbers have to be, that's negative 6 and 1. So 3 tan square x, this is going to be replaced here by minus 6 tan x. I could have started with 1, but of course the 6 and the 3 goes nicely. Then 1, this positive now, positive 1 tan x, okay, factorizing. take away 2 is equal to 0. Here common factor is 3 tan x outside. Then you have tan x minus 2. And then here common factor is 1 because it's just already tan x minus 2 over here. Right, so let each of those things equal to 0, or let's just take it step by step. So we have 3 tan x plus 1. It's going to be in its own bracket. Then you write a common factor only once. Right, so given that two things give you product of 0, it means that 3 tan x plus 1 is equal to naught, or tan x minus 2 is equal to naught. That is not just tan, there is also something in front, tan x, and is equal, minus 2 is equal to naught. All right, so what do we have for tan x? We have here that tan x is going to be negative a third, or tan x is going to be 2. Now, let me just go back and see what is it that I was supposed to do. What did the question ask of me? Okay, we're supposed to solve, but then our domain is between 0 and 180. Now, looking at this, our domain for the tangent, okay, when you look at the cos diagram, the tangent is positive. Our domain, so if I do 2, so I'm not going to consider this ones because it's only from 0 up to 180. Make sure calculate this in degrees mode. So let's take when it's positive. Here it's positive. When it's positive, it happens in the first quadrant. The next will be the inverse tangent of 2. I'll write down what that answer is in a bit. If it's in the third quadrant, because all of them are positive here, here is only sign that is positive, so tangent is negative, okay? So in that second quadrant, x is going to be 180 minus, now remember, you have the inverse cosine of a third, so I'm using the acute basic angle. Okay, you're going to put the minus there in order to isolate the x, all right? So basically you're saying, here you're saying that x, to find the acute basic angle, or a reference angle for that matter, okay, you say the acute basic angle, okay, when the ratio is a third, is going to be the inverse tangent of a third. Now, once we have that angle, which is what I did over here, and because it's in this quadrant, you have to say 180 minus that acute basic angle, minus ABBA. You get it? And that is going to give me the two solutions, okay? One solution being over there. So let's grab our calculator. Make sure it's in degrees mode. Mine is not, so I have to bring it back to degree mode. And you must be very careful. That's 3. Right, so which one are we doing first? Okay, we do when it's positive, so the inverse tangent of 2. Okay, we can grab that. So I'll just grab that, grab a screenshot of it, paste, bring it over here. Okay. Then do the second one where we say, okay, it's 180 minus, of course, the inverse cosine of 1 upon 3. Let's close these brackets. Okay, 180 minus that. Do we get 109? Okay, 109, just checking, maybe I have done a little bit of mistake. Let's see. When it's negative, let's suppose we do that. Let's leave the 180 for now. We get 70. Okay, right. In the second quadrant, it is negative. In the second quadrant, our angle is negative. Our angle is negative. I think I've used cosine. My God. No wonder. Where does the cosine even come from? This is a sign that I'm probably getting tired. Right, this is not supposed to be a cosine. Mr. Max, we are dealing with tangent over here. So I was wondering, why am I getting a funny looking answer? So it's tangent rather. Okay, so it's the inverse tangent of that. Of course, let's go back and get our answer. The first part is fine. I worked the first one with positive. I worked with the tangent. So it's 180 minus, in bracket, I have the inverse tangent of 1 over 3, that basic angle. Now it sounds better. Now it sounds better. All right. Capture that. Let's have that. Bring it. Come meet your friend over here. All right. So my two solutions. Therefore, x equals to, it's degrees, so we're going to give to one decimal place, 63.4 degrees. And x equals to 161.6 degrees. This is correct too. One decimal place, that is the preferred degree of accuracy. So 1 dp. All right, there we go. So yes, though that was my three-part series on questions very quickly on further trigonometry. Hope it has been useful as much to help you with your, whether you prepare for examinations or whether you just want to improve. Okay, so this is part 3. You can always go back. It wasn't really that complicated. I prolonged it in my explanation, but it was very useful to be able to go through it step by step. And I would suggest that you go look for past question papers, where it's Cambridge papers and so on, and you work them out. It will help you with your preparations for examinations.